So I was talking to somebody who Amar and I know mutually, Vish, and we're talking about electronics manufacturing and reshoring. As some of you know, that's been my passion for the last year or so. And one of the things that Vish told me was, you should go talk to Bright Machines and Amar. And when I came across the machines, first my inner geek took over, realizing that they're using all this technology to actually build actual machines. And then also, just in terms of reshoring and specifically around electronics, it's a pretty big market. It's like the whole ecosystem is expected to be over 7 trillion by 2025. 75% of it is manufactured in low-cost countries because so much of the work still requires manual labor. And if you're going to reshore, you need automation. And so I was quite excited when I came across Bright Machines because they're doing exactly that. Amar, maybe we can just start with your background,
Sure.
how you ended up here. And then a little bit about the history with Bright Machines, and we'll let you do your presentation. And I'm going to stop sharing the screen.
Sounds good. Well, Harinder, thanks for having me. I appreciate the opportunity to speak to everyone. You can hear me okay, right? Because this might be my 17th Zoom or virtual session of the day, but this is my first air meet. So this is going to be an interesting experience. So, and the other thing we just have to get out of the way is that while Harinder and I both have the same last name, it's not like we are brothers or anything like that. There is some genealogy going way back where I think our great-grandparents may have been in the same village or something like that. But so anyway, so just want to, actually how we got connected on LinkedIn was, hey, man. But anyway, so in coming to today's topic, so I am the CEO of Bright Machines. Prior to this, I was at Autodesk for probably close to 27 years. And my last role there was the co-CEO of the company. And in the years prior to that, I led the product organization for Autodesk. So I think some of you are familiar with Autodesk as a CAD/CAM company that builds 3D and analysis and simulation and visualization software for both manufacturing and building customers. And in 2017, after I left Autodesk, I'd been thinking about sort of what I'd seen with the last 5 to 7 years of the early, from 2007, 2008 onwards, was how much SaaS had changed the world of enterprise software. And, it seemed that SaaS had sort of, as technologies evolved, really changed the economics of deploying large-scale enterprise software. And I've been thinking about, so if cloud computing was a current wave, what was going to come next? And it was clear to me that technologies such as machine learning and computer vision were the ones that were going to sort of define the next wave of technologies, and IoT, so data as the platform, as opposed to just cloud infrastructure as a platform. Like, what could you go do with that? And in thinking about areas that we could go address, manufacturing and factories kept coming up as like, what could we do to reimagine the way factories were run? Because one of the things that we had seen was a tremendous evolution in the way software had been developed. Like, if you think about how software was created 20 years ago and how it's created today, 20 years ago, you came to a software company and said, hey, you can deploy 7 times a day. They'd look at you going, are you insane? Like, all of that had changed. Like, the whole agility and flexibility and global distribution of software had changed. And so I've been thinking about, like, why is it so hard to do it to physical products? Like, why can't we do things with physical products that are like digital products? And, what would it take to do that? And, 3D printing was one example, but it was not enough. Like, what else could you put in? And lo and behold, like thinking about machine vision, computer vision, machine learning, you start looking at, okay, there are ways to take the parts of the manufacturing workflow that are still analog and manual and reimagine them. Because, the real lack of agility in manufacturing has to be because, you have to train a bunch of humans to go do a bunch of things. So could you go train a bunch of machines? And the idea behind Bright Machines, and literally that's in our name, is how can we give eyes and brains to machines? And so can you use computer vision, can you use machine learning and teach machines how to go do the things that you're today reliant on humans on? Now, I know it sounds like a dystopian, you're going to put all the humans out of work. But in reality, what we started to create was a manufacturing platform. So just the way that an Amazon Web Service server is blank, it doesn't have any information on what you're going to do, what you're going to store. It just responds to, what your query is. In some ways, in manufacturing, the right sort of end state to get to is to build a platform that you can program and say, make this, now make this, now make this. Now, that's a 20-year vision, right? It's got a lot of things to go do. But the first problem we decided to go solve is you cannot achieve that vision if some tasks are still manual. And the most manual task in a factory is assembly. So could we go take machine learning, machine vision, and go attack this problem of assembly, testing, inspection, sort of the places where humans are valued for their flexibility, for their dexterity, and are machines good enough to go do that? And that was a fundamental premise behind Bright Machines. And so we started this company in 2018. Half our company comes from a software world, and the other half of our company comes from manufacturing. My co-founder came out of Flextronics. So, he and I kind of met in 2018 and sort of had this yin and yang moment where he's like, you know what, I've been trying to automate for many years, and the biggest barrier to automation is that there's no software to automate automation. And I'm like, okay, I know how to build software. And the thing that I've been thinking about manufacturing is there's no process expertise to figure out what to go digitize. And that's kind of the genesis of the company. It was like, hey, could we go do this thing together? And that's sort of how Bright Machines was born. So that's a preamble, and happy to tell you about who we are, what we do. But before I do that, Harinder, is there anything else you want me to sort of give as part of the background?
No, that was perfect. In fact, so we have, turns out, we have a lot of robotics enthusiasts and practitioners in the group.
Yeah.
And when Bright Machines came up in the discussions we had on Discord, I noticed there's always the robotics guys who are getting excited. So, okay. And I see some of them here. So okay. That was perfect.
I'm in trouble now because look, here's the way we think about robotics. I mean, with all due respect, we treat robots like Amazon treats servers. Like, it's like we're thinking of it almost like a commodity because in a good way, robots have become very reliable and increasingly programmable. And so what you'll hear me describe is we use robotics in our solution. We are not inventors of robotics. So we look at, actually the better example would be, we look at robotics the way Dell looks at CPUs. Yeah. So, it's a very core component of what we do. We really do select a robotic partner carefully, but we're not the inventors of the CPU. We just use it for what we do. So let me go ahead and tell you a little bit about our company and how this goes about. And let me see if I can, Harinder and I had a bit of an adventure seeing if we could make this work. Does this work, Harinder?
Yes, you can see it. Yep, it works.
Brilliant. You can see the blue screen. All right.
Yes.
Okay, so here goes. So our mission as a company is to build that intelligent platform I described for industrial automation, but really for industrial production. But the problem we are focused on is deploying intelligent assembly lines. And the reason we chose that problem, I described that. It's clearly the biggest barrier to enabling things like reshoring, as Harinder. You cannot move production where you want it to if labor costs are your biggest barrier. It's also a problem that needs to be solved to build manufacturing resiliency, because if you have things like pandemics going around the world, you can't have a resilient infrastructure if it's dependent on humans being available at all times. And then beyond that, the original problem set where how could you increase agility? How could you increase scalability? How can you improve product quality without making a more expensive solution? We really thought assembly lines was a unique problem to go after that. I see there's a typo with CR in my, but it's like, this is what I told you about the yin and yang. And then everything that we're doing in terms of software really is based on computer vision, machine learning, some 3D technology, some control software, and cloud computing. So you guys know the background. We really feel that manufacturing is kind of reaching its limit in terms of, the demand of products is going up, the availability of labor is going down, and you have all these challenges coming up as a result of that. The other thing about manufacturing that is it doesn't have a closed loop, dynamic closed loop. Like you can't quickly improve it. You can improve it, but the cycle times are slow, in terms of getting data, finding things. Like other systems that have become very data centric have a much more continuously improving environment. So what we are building for assemblies is an environment where we have a configurable set of hardware to go build a range of products, and that those systems are taught and run through software, and that the entire instruction set and control is done through software. So there's a couple of things about this that's different. One is that the state of the art in automation out there for assembly lines in particular is everything is custom. And this is why, because automation takes too long and it costs too much, automation is only applied when you have very high capital projects. Like that's why you see robots in cars and aerospace factories, but you don't see them making your coffee maker, for example. And the same thing applies to cycle times. If you have a product that's revving itself relatively quickly, the current state of automation is by the time you set it up and you're revving your product, you got to throw away the automation, right? So, you don't get it applied to a very wide variety of products. And so by using this modular configurable approach, that's the first thing that we're doing that's different. So we snap together our system like Lego blocks, and then we teach it what to do the way you would give an autonomous car instructions on where to go from A to B. And that's overly simplifying it, because there's a huge amount of stuff that needs to happen in order to make this work. So what happens here, for example, is the central idea we have is we are programming not a single station. So we're not programming a robotic arm as much as we're programming the entire system. So we synchronize the action of 8-9 things that need to work together, from feeding systems to transport systems to robotic arms to vision systems to end of arm tools, all of that. So we're programming at a system level, not at an individual device levels. And today, again, the state of the art is there's a programming environment for the robot, there's a programming environment for the conveyor, there's a programming environment for the feeder. So, anything happens, you got to move everything all the time, every time. And the other thing that tends to be the case is, these systems, especially robots, really are somewhat blind. They don't know where they are. And calibration, or being able to locate things in physical space, is a huge part of making these systems dynamic and be able to handle things like warping, vibration, feeding errors, all that kind of stuff. So our software stack takes care of all of these ideas, from creating the instruction to sort of making that instruction work in physical space, et cetera, and deploy over cloud. So I'll just skip over. Well, there's, we do path planning. Yes, we can do all of that, teach the robot what to do, all of this stuff, and by doing that, what we end up with is the equivalent of what we would call, Alexa calls skills. The idea here is that the combination of hardware and software means our systems learn how to do things. In one way, if one of our systems learns how to insert a heatsink, all our systems learn how to insert a heatsink, because we kind of have software-based, software shared, we get a hive mind. And in reality, of course, every heatsink is slightly different. So what you're really doing is you're short-circuiting the learning process by 80%, kind of thing. And then we can apply these skills or combine these skills to build various products. So whether it's a home security system or a drill or a fire alarm or a broadband infrastructure box, effectively building these things is a combination of many of these processes, and our systems have learned how to do many of them. And that's kind of, Bright Machines, that's why we're able to use a modular approach using these skills that are software-based, some end-of-arm customization, and we can do this concept we call design to dock, that we can deploy these systems today in 16 weeks. You ask me next year, we'll probably get it down to 8 weeks. And that's something that, is really unusual. And of course, because it's all digital, the data coming off the line can be certainly viewed, monitored, analyzed, and then it can be used in a continuous improvement process. So, you're digitizing the assembly and inspection process in this environment. So, well, it's trying to do a video, but it's not working. And so, I give you one example of sort of the using this approach, what we've been able to do in terms of defect rates, the amount of quality improvement, the improvement in units per hour for an infotainment system in a car, for a media hub inside, the home. And we've done over 50 projects now for customers since we brought the product out in 2019. So, the system is proving itself. We have a long, long way to go. I know when I'm presenting PowerPoint, it's easy for it to sound all perfect, wonderful, it all works. But in reality, this is a hard technical problem. It's easy for me to describe it, but there's a lot of really difficult problems you have to go solve in software in particular to make this all work. And we're well along our way, but we've got a lot left to do. And, we've got a talented bunch of people in Israel, in San Francisco, in Austin, in Seattle, and then we have a bunch of people in factories around the world in China, Romania, Poland, Mexico, deploying the solution for behalf of our customers. So that's a quick overview of who we are, what we do. Happy to go into any level of detail that you'd like me to, and that would be helpful to others on this call.
Okay, thank you. So, folks, don't forget, you ask your questions, you click the icon. Oh, somebody is raising their hand, and let me bring him in. Oh, Kia.
Go ahead.
Hello,
Right.
Thanks for that great presentation. I'm still kind of trying to, the concept sounds amazing. I remember talking to our machinist 20-something years ago. I said, well, why do we need machinists? Why can't we just automate all this stuff? I'm kind of curious to see a little bit more detail in terms of how you guys are actually doing this in terms of technology. My understanding involves computer vision, what have you. I don't know if you can disclose it or not, but how are you actually doing it?
I can only look here. Am I saying your name right? Kia is the right way to say it?
Yeah.
Yes.
Okay, so look, I mean, there's some stuff I can say only after an NDA, but I would say,
Okay.
let me describe the general idea is, you have to write a bunch of control software for the actual devices. So you're writing device drivers to control a bunch of individual components, and sometimes the components are, robotic arms have a reasonably well-defined interface, and other times you have to get very low level to control motors and things like that to write, things that control conveyors. So we write a bunch of device drivers, and there's a way for us to abstract, just like, in Microsoft Windows, you have device drivers and you have the whole sort of print pipeline, and you're able to abstract up and up. And so we can take, for example, a command that says stop conveyor. So from a programming perspective, we can give someone a command that just is English text that says stop conveyor upon certain condition. And then at the low level, the device driver is translating that into some kind of synchronization mechanism. And so at a control software level, that's what I can share. At a vision level, what you're trying to do is help the system locate where everything is. And so, typically robot paths, or let's just use robots for example. Paths are programmed using that stupid, horrible, giant remote control to keep doing, here, go do down, this kind of thing. Now, so in our environment, you have a 3D environment to go do these things, or you can textually type in coordinates, but you can also teach our system to recognize parts and locations, through a training environment. So now it can recognize what the heat sink is, and it can recognize a slot on the heat sink. So you effectively can tell the robot, find the heat sink and insert it in the slot. And then it kind of, then there's a bunch of proprietary technology that's all about, locating and placing those things. So that's what I was trying to say earlier, is that there's a lot of stuff. And of course, when you're placing things, it's not just about locating things. The robot has to know where it is in physical space in 3D. So it actually has to know in its environment, what the digital coordinate system versus the physical coordinate system is. So there's a bunch of technology that resolves those things that we've gone off and started to invent, is the more honest answer. Mm-hmm. And you then combine these concepts to go do the stuff. There still is a bunch of mechanical engineering involved. Every product is unique. So our process engineers also have to figure out how do they pick the right end of arm tools, how much torque to apply. So you can't just say screwdriver, you have to tell it, apply 40 torques, 40 whatever newtons. So all that kind of stuff you got to figure out, how to do. So there's a lot of detail behind this that, if you come in and, you start working with us, we can tell you.
Okay. Sounds good. Let's talk afterwards.
Kia is one of our resident experts on all things manufacturing and product design. Yeah.
Right. Because I hear what you're saying. We just sent some, for example, we sent some PCB boards overseas to be made in China.
Oh.
And the price we got was substantially lower than US. So I'm all for onshoring. I think that's the term you used, which is a great term. I'm just a little bit still skeptic of that concept that you can actually do these things. This having a pick and place robot, automated, great. Having a PCB fabrication, great, automated. Still, you have assembly, and you have QC. So there's a lot of steps, and you obviously know this, right? So I'm kind of really interested to see how this is a great idea.
Payman, I would say if this was not COVID, I would invite you to come see our Austin facility, where we're actually actively working on maybe 12 projects right now. Uh-huh. And that would be the best way. I can talk till I'm blue in the face until you see it. Someone with your background is going to go, hey, man, that's like a bureaucrat spouting a bunch of bullshit.
Yeah.
Fair enough.
All right. Cool. Thank you, Kia.
No, thank you.
All right. Hang on. I've got some more questions here. Okay. Let me bring in Usman, who was next. So, folks, when you ask the question, can you raise your hand as well? The question is, the reason I'm asking you to put the question there so other people can see what you've asked. And that way, it's just easier for me using their interface to bring you onto the stage. So please remember to raise hand right after you ask the question. All right, we've got Usman next.
Let's see.
Go for it, Usman.
Now?
Sure.
Oh, yeah. Thanks so much for doing this. It's a really interesting, I think maybe one of the most technically challenging problems out there, and I've been thinking about it a lot myself. So I was wondering, you said you might get next year from 16 to 8 weeks. Oh, am I muted? Can you hear me?
Yes, I can hear you. It's fine.
Oh, okay, sorry. Yeah. Yeah, so you mentioned that you might get from 16 to 8 weeks, and I'm just curious about, like, what does it entail to really chop it down that much? I mean, obviously it's a really big increase.
Yeah. No, there's two sides to that problem. One good question. One part of it is it is the software, because you think about how long it takes to configure and calibrate these things. Because I would say we've done 50 projects, but every product is unique. So when we get a product, this is like saying, if I I always draw the analogy between automation in the hardware world versus in the old days of enterprise software, companies would come and say, hey, can you write me a CRM system? Can you write me this is like everything was unique, right? And it just took a long time to where you started developing common sort of components. And I think one part of it is the more projects we do and the more common components we develop, the faster it will be for us. So today, if we look at electronics in a box, and you came to us with, let's say, a broadband network infrastructure project, we could probably do that in 12 weeks. So, like what we've noticed, so the first project took us 16, the next one took us 14, because we've got more stuff, ready to go. And today, if somebody came to us, we haven't done, for example, a medical device like an inhaler, asthma inhaler. If somebody comes to us and says, can you assemble this for me? It'll take us 16, 20 weeks to figure that out. It just is a bunch of... So one part is just having enough scale and doing a bunch of projects where you have this common sort of leverageable IP. The second one, this is going to sound really boring, but in the world of hardware, you need inventory. You have to figure out long lead items. All that other nonsense takes a lot of time. So, for example, when we found out, for example, we started making a consumer product for people, the feeding system for plastic parts is very different than the feeding system for electronic parts. And the feeding system for the plastic parts takes 21 weeks to deliver. It's because somebody else makes it, right? All that kind of stuff. So that's what we would figure that out and have more stuff in inventory. So there's a bunch of that. And then the question really, below 8 weeks, it doesn't actually make sense to do it. You start reaching diminishing returns. It only matters if people are making minor revisions to existing products. But if you're introducing a new product, customers are not just doing our stuff. They're trying to get supply chain. They're trying to get other stuff wired in. Below 8 weeks, they're like, dude, you can do whatever you want. We're not ready to use it. You know what I mean? So anyway.
Yeah. So customer needs to be ready as well.
Exactly.
Yeah. And that's cool. Anything else, Usman?
No, that's it. Give me a lot to think about. Thanks so much.
All right. Okay. Thanks, Usman. Colleen.
Hi. Are you able to see me and hear me?
I can hear
you.
Yeah. Oh, okay. I guess that's the important part. Well, thanks so much for your talk. I was just wondering if you could speak more to your product design process, especially in terms of the user experience. You talked about having learned from software, kind of the software startup world. So I'm wondering if you've done the same in terms of developing a lean and user-centered UX process for your hardware.
It's a really good question. So my honest answer on that, Colleen, is the hardware UX isn't great. We have a very engineering culture to the hardware that we're building. It's very industrial. So I would say one of the things that we defaulted to on the hardware just in the beginning was reliability was like you couldn't have things move around on the factory floor. You find these, small errors can make a huge difference. So the first thing that I think our hardware team went off and did, they literally built tanks. Like these things weigh a ton because they are made of like really strong metal. So they didn't give us a lot of room for industrial design innovation. And, at least the initial project set, the initial cells that we've created, really defaulted towards making sure that they were reliable. And the one other thing I would say is that in the world of manufacturing, nobody gives you credit for being innovative if the stuff doesn't work. Like the premium is on reliability, and then the other stuff kicks in. So I think in our first iteration of 1.0, we really over-indexed on kind of being utilitarian and really didn't run a very good product design process on the hardware side. Having said that, now we are. Now in our 2.0 iteration on the hardware side, I think we've been looking at ergonomics in the sense of like, well, all the stuff that users need to interact with. There's a touch screen that you see on our device that gives feedback and also some level of control. We've been looking at how people interact with that. We've been looking at serviceability and access as well as safety. So you kind of redesign that system, and probably sometime next year you'll see in our 2.0 the fruits of that process. Now, the other thing that I just would register on the UX is so much of what we do is the software aspect. And there we have stuck with our traditional approach of really using software. We heavily use Figma in our company. So it's meant to sort of be collaborative and try to tie the people who are using the system in the factories with, relatively small UX team that's designing the system and get some real-time feedback. And, and we try and update that experience every 6 weeks. We have a release that updates that experience and, acts on the things that people are giving feedback to. So that's kind of our process so far.
Okay, thanks. And just one quick follow-up. You mentioned a small UX team. Are the folks working on the software the same ones working on the design for the hardware?
No, they're different. So the software team, the small team in software is based in San Francisco. The hardware team is based in Israel. And we've done that for a reason, because in some ways having a Chinese wall between and I don't know if that's an inappropriate reference, but I don't know, that sort of separation, it actually prepares us someday to make our software work with an arbitrary set of hardware. We've been thinking about the way we've been developing our software today is very tied to the metal, but long term, we want to really separate or abstract the platform out and let our customers, if they want to change a Fanuc arm for an ABB arm, or they want to use this or that, create their own versions. We want to create that. So we've kind of kept the arm's length between our hardware and software team. So our hardware team is in Israel and uses a different process and different UX support team. So.
Okay, thank you very much.
Thank you, Colleen. Yeah, that makes sense. In terms of 1.0, you want to focus on making sure the machine is doing its job, right?
Yes.
It can look pretty, but it still needs to do its job.
Yes.
Okay, so we have Stuart coming in.
Hi, yeah.
Hi, Stuart.
Hey, Stuart.
Good to meet you. It's a nice presentation. You've got a very cool product. I like it.
Thank you.
I was kind of curious. Well, one of the things about the audience that you're talking to is that, in some respects, we're seeing it as potential customers of if we wanted to build a device, how do we go about doing manufacturing lines? And at the same time, we look at it from the standpoint of you guys are in some ways a hardware startup, and we could learn from your approach to things. Following on that second point, I was kind of curious, what are the other companies that are doing stuff like what you're doing, and how did you decide to differentiate, and why did you choose the path that you did?
Right. Good question. There are two types of companies that are in the same problem space that we are. One of them, they're point products. So you find people that are building robotic programming interfaces. There's a lot of RoboDK and there's 7 of these guys that are out there. They're all very good. And there's somebody that does environment for 3D simulation. So one way that we just decided to do was say, can we just tackle the whole problem as opposed to individual? So in some ways, the equivalence would be in the world of software, there are people who are developing middleware. and applications. And we just basically took the vertical application route. So we just decided, hey, we'd do the end-to-end experience. So that's one way we differentiate and try and get above the middleware stack. And the second is that the incumbents in this space, if you leave labor aside, the incumbents are the giants. They're the Siemens and Omrons and Honeywells and Rockwells of the world. And they have tremendous expertise in building complex lines, but their software expertise tends to be lower. So both answers came out to be software. Now, the one thing we were fortunate on, and I would say I cannot underestimate, we were able to raise a tremendous amount of financing in the company because it's a hard problem. This is one of those things, like, I do think that by the time us or somebody else solves this is not SpaceX, but it's going to take a tremendous amount of energy, effort, sustain. So without that, I don't think we could have done what we're trying to do. Honest to God, if we were a startup that raised $5 million, we'd be done by now. There was no chance that we could go after. So by being fortunate to raise that capital, we could actually try and solve the system problem. Had we not raised that much, we would have never been able to go after the system problem. So I think differentiation, at the end of the day, the one thing that we consistently see is a level of software expertise out there is not high. User experiences in the world of manufacturing, the user experiences tend to be 1960s, at best 1970s. Like, those are axes that you can really clearly differentiate on. And but the one cost of entry is that the stuff has to work, because the people who are doing production have no patience for, this looks nice, this is the future. They're like, it either works now or go away. That's very important that you have a reliable, practical, working technology. So,
yeah.
Cool. May I ask a follow-on question then?
Sure.
Okay, so on the topic of raising capital, that was one of the things I was curious about, because you seem like, a company that was able to kind of, floor it really fast, and from a financing and like get things going standpoint. And I've seen the same dynamics in the grocery store industry where, it's kind of hard to break in as a small, like $5 million funded company, right? Whereas so the ones that start off are like the ones like Ocado, which already have like just bucket loads of money and resources. How did you guys, what was it that enabled that path for you?
Well, we had one anchor customer that we started with. So I think the one thing in terms of what's common between us and Ocado is that you need a business that kind of supports that level of investment. And either you start with, in case of Ocado, they had a grocery operation that they were funding with, using it just like AWS, that they had a front end that funded the back end, right? So you either do that, or you have a customer that makes a substantial commitment. And in our case, we did start with a customer that was willing to sign a 5-year contract that was massive in its implication. And it was also reasonably binding, that they were really committed to large quantities, because they really had a need for automation. They were like, and they also had realized that in order to do this, it was a software problem. They couldn't bring talent in-house. And so they were willing to let somebody else fund. So their balance sheet was small, but their OpEx was large. So they're like, we can fund the buying, the labor arbitrage, but we cannot fund the big one slug of capital to go do the R&D. And so that's kind of the win-win we were able to construct between the customer and the fund, the investors.
That totally makes sense. And then that large anchor customer, they have a decent equity position.
They have a decent equity position. Yeah. They have stake in the game. I mean, they're smart people, so they will kick us out if it doesn't work. But we did sort those things out with them. Yeah.
Makes sense. Thanks very much.
Sure.
Thanks, Stuart. Yeah. So you used the analogy with the PC and the CPU as you're having the discussion with Stuart. I think a SaaS analogy, right? Where today, if you're a user of SaaS, you're not having to buy the server, sign up for the EC2 instance, and then get the integrators in to do this.
Right.
And what's complicated here is you're now
Right.
adding hardware too, right? That needs integration. And and the skill thing is a big deal.
Right.
Exactly. GE, I saw this at GE. GE was running a bunch of ads to compete because they're competing against the Facebooks and the Googles.
Yeah.
It's hard for them to recruit people. So cool. Okay, Frank.
Yes, can you hear me, Amar?
Yes, sir.
Yeah, thank you so much for the presentation.
Of course.
So I'm wondering from your side, this autonomous manufacturing assembly or automated manufacturing assembly, will it start at the product design?
Eventually, I mean, it makes sense that I think you can connect engineering to manufacturing where, you see, so there's an analogy to the world of, so you think everything I'm describing today on the world of assembly sounds amazing and all, but it's been done before in one other parallel industry, and that's the semiconductor industry. So you think about the way chips are made today. There's a very large manufacturer, TSMC, and there's a couple other ones, of course, Intel and Global Foundries and these guys, where the engineering organization kind of knows how the product is actually going to be manufactured, right? They actually get libraries to use in their chip design as they're designing whatever they're doing. And that, you just digitally dispatch, and lo and behold, from the great manufacturing facility comes back your product. So I think that is the future for all different types of products. But there's a few steps to getting there. I mean, I really do think that this is the eventual state we land in is as somebody assembles or designs products, the instruction set for how to make that kind of gets abstracted out of the products that are being made. Parts get identified, they get assigned to various machines, they get built by the various machines or sourced from commodity suppliers, and then they get assembled, and it's a very large problem set. But yeah, I do think that the product design, there's that's what people want to do. And the other thing that I think, Frank, is the many product companies eventually, what we're doing today is still playing in the high volume, low mix, or medium mix, medium volume game. Ultimately, manufacturers want to do high mix, low volume, right? And so to do high mix, low volume, you really have to integrate engineering. You really have to have a very tight loop between what you're designing for the customer or how you're iterating with how you're making. So it is the eventual destination of all of this. I just don't know how long it'll take, because culturally, the industry has a few barriers. And I think a lot of these things are not technical problems as much as they're cultural problems to overcome.
All right. Thank you for that.
Of course.
Thank you, Frank. Okay. Usman's back. And I see there was a couple of questions, Mike, Varney, and Gil. And if you guys want to ask your questions. What happened to Usman?
Mike's question is in text form as well. I mean, I can answer that.
Yeah, if you want to do that, go ahead.
Yeah. Mike's question was, not being a manufacturer, most of my discussions are around MES and OPM software solutions. How does our solution fit with those solutions?
Yeah.
I mean, roughly our stack is like DevOps for automation, right? So if I was drawing a software analogy, so an MES is more a system of record than of actual control. And the way we interact with MES is we read and write data from it. So, for example, when we're assembling something, if we need to put a barcode on the board, or we get the number from the MES system, we don't generate it. And then if we are scanning something or we need to report back a part number into the MES system, we can take a picture and we dispatch it. So MES is sort of like a database we read and write to. We don't try to replace it. I don't know about OPM. I don't think we've run across that. But MES is a very complementary system. Now, how all this stuff evolves, I don't know. But today, there's at least 3 implementations we've done where we're receiving and dispatching data from MES systems. So it's very complementary.
Great. I'm going to try bringing Usman back in. Hopefully it will work this time. There we go.
Yes, sir.
All right, looks like I'm back. Yeah, back for more. So kind of taking a step back, right now we got a little bit into the details, but I was wondering, from a perspective of your stated goal of bringing the agility and kind of tight iteration cycles of the software world to the hardware world, what are the main technical challenges? Because as a company, you guys seem, from my understanding, that it's not so much about the individual components, it's about integrating these components. So we have companies that do great computer vision, we have great robotics companies, but from a technical perspective, it seems like a really challenging problem to have that kind of network control of all these different components. So I was wondering if you could speak a little bit to the overarching technical problems going forward.
So Usman, I want to make sure about I understand one part of your question. Are you talking agility for us to iterate our product or for our customers to iterate their product?
For customers to iterate their products.
You think about that. What I've seen about sort of so one, I'll leave the cultural side alone for a second. One is that there's a lot of detail. I mean, when you're making a product, there's a lot of complexity in making these products, right? So, I mean, a coffee maker doesn't sound that complex, but I think about like, if I look at an autonomous, we're actually working on a project today for an autonomous car where they're sort of assembling the thing that the control computer that goes in there. And if I look at that, there's a tremendous amount of sub-assemblies or design that has to happen between memories, compute, sealing the whole thing, screws. So I think that I'm trying to think about the engineering challenges on that is the sheer amount of specialization that is required in building some of these products means that the coordination between different types of engineers, people who do electronics, people who do plastics, people who do mechanical, it's not easy. And so you end up with people who end up with different tool sets, people who end up with different, sometimes locations, and that coordination is not, I think that's really hard for things to come together. And so what we observe constantly is people are changing the design. We worked with one customer today, this year, who's been building a fire alarm. And then you think about a fire alarm, you go, like, that's how complicated is that? You look at it, plastic, one PCB, like, how big is that? They've been revising their design for 6 months. And it's like, okay, this time the UL guys rejected their thing. This time, they keep having to do stuff. And I don't know if it's technically complex, but I think the amount of coordination involved, because all these products are trying to get quote unquote smart. And so they have now electronics, they have software, they have plastic, they have mechanical. That thing is not easy. And there's no one software. SolidWorks does mechanical stuff. Altium does PCB. Something else does something else. And then you end up with this level of detail where they're not specifying the screws, they're not specifying the springs, they're not that's where these guys get hung up. And then agility becomes like a information sort of challenge. Is that I think becomes the biggest. How do you have all the information coordinated, and then you can move it into manufacturing? I think that tends to be the challenge that I've seen.
Right. So it's not just about the complexity itself; it's about the scale of the complexity.
Yeah, that's a good way.
All the different parts going on.
It's a good way to put it.
Interesting.
Yeah, that makes sense. It's not just culture. It's also your ecosystem and how it works, right? Anything changes, you need to change everything else, and if it changes frequently, you need to adopt it. Yeah. So cool. Okay. So it looks like Gil actually left, but he had a question. Usually, manufacturing factories owned by the OEM.
Yeah.
How do they mitigate the risk of BM owning Bright Machines owning their manufacturing intelligence and being a sole source provider?
Well, we don't own the manufacturing intelligence. So we deploy the machine. It's just like any other machine. We build it, we deploy it. It's in their factory. They own it. They run it. The data is with them. We don't see it. So this is not a conflict.
Okay. All right. I think that was the last of the questions, and we ended right at 5. Okay, folks. I think that was it. If there's no other questions, thank you so much, Amar. This was awesome. It's exactly what I expected. I'm excited. Hopefully, we'll get some of your techies to come out and share the details. As you can tell, we have folks who are quite interested in how these things work. But this was fantastic. So you're welcome to stay, join in the lounge, meet other people. Otherwise, thank you so much for this.
No worries. Thank you so much. And then, we do have an office in Seattle. If any of you guys are really interested in getting a little bit beyond the details, let me know. I can connect you to the right people over there. So thanks everyone for your time. Be well. Be safe.
Thank you.
Take care. Bye-bye.
I'm going to stay here.